hi everybody. My name is Scott Holstein, and I'm the Director of Marketing and Business Development for Computrols. Welcome to our webinar today. In case you're not familiar with Computrols, we are a manufacturer of building automation systems controlling specifically HVAC, lighting, access, and fire alarm systems. We also provide tenant-facing systems for commercial real estate, including tenant overtime systems and tenant-facing dashboards. You'll primarily find our technology in commercial real estate, hospitals, hotels, and higher education facilities. Before we get started here, I just want to take a quick moment to thank all of the facility managers and service partners who have been working through the COVID-19 crisis. We appreciate everything that you all have done during this time. Today, we're basically here to help you out as much as we can. We want to give you some ideas on how to improve the health and safety in facilities, specifically focused on indoor air quality, but we'll also talk about some other measures to prevent virus spread. And we're going to record today's webinar, so we will be sending that out probably later this week. This webinar should run about 1 hour in length. We're going to leave some time for questions at the end. If you have a question, please go down to the chat bubble and enter your question there, and I will bring up your questions to the presenter at the end of the presentation. Anything we don't address at the end of the presentation, we'll do our best to get back to you by email. Today, I'm joined by our Director of Research and Development, Mike Donlon. Mike is also one of the owners of Computrols. Mike received his bachelor's degree in electrical engineering from the University of New Orleans and returned to UNO to get his master's degree in engineering, where he focused his studies on computer vision and image processing. In 1989, he was hired by Computrols as the principal software developer for the original CBAS software system. Since then, his duties have been to oversee all software and hardware development for the company, as well as researching and applying new technologies to building automation. His recent areas of interest include machine learning, building automation system modeling, and open source technologies for building automation. And Mike, I guess we can also add indoor air quality to that list of your interest and things you're really becoming an expert on. If you wouldn't mind, Mike, go ahead and take it away.
Welcome, everyone. Today we're going to cover indoor air quality and COVID-19. And we've done a presentation similar to this about 2 weeks ago, and this one has changed a little bit. Things are moving so fast that surprisingly new information has come out just in the last few weeks, and we got a little more organized about our response to it. Let me first introduce Computrols. For those of you who don't know, we're a building automation company, and we design, manufacture, install, and service building automation hardware and software. This software works on multiple systems in buildings, and we feel that in using multiple systems, it creates synergy and value that you really don't get from single system type automation systems. So we're going to cover a good bit of that today, but going over those systems, of course, HVAC controls is our largest sector that we deal with, but also we do fire and life safety, access control, metering, energy management, lighting control, indoor air quality, and of course recently we are working with COVID-19 mitigation and things like that. Like all of us are sort of being put in that position to do that. So we'll go over this presentation in 3 sections. One is virus transmission, and we'll share what we know about virus transmission with you guys. It's important to understand that as we move forward and work with indoor air quality and do virus mitigation. Second section is covering indoor air quality itself and some of the main concepts. And then finally, we will go over virus prevention measures, which, you know, sort of combine all of the 3 things together.
Bit of technical difficulty. So virus transmission, we're going to go over the science of virus transmission and look at some virus transmission studies. So let's get started with that. Get a quick definition out of the way. I'm sure everyone has heard all of these words before, but just to be clear, There are two elements, and we make a clear distinction between them. The first is the virus itself, which is named SARS-CoV-2, not a very catchy title. And I think people get that somewhat confused with the old SARS virus, but this is the sort of -2, the new version of it. And then COVID-19 is the name of the disease that humans actually contract when they get infected with SARS-CoV-2. So with those definitions out the way, we'll look at some key points. So SARS-CoV-2 is a novel virus. Research is ongoing. So novel is sort of medical speak for new, and that really has two repercussions. One is that we simply don't know that much about it, and we're learning continuously. But also, because it's new, people don't have immunity to it, and that's one of the main reasons why it is currently so dangerous, is because everyone is susceptible to it. You get that sort of exponential spread with novel viruses. So measurement and customizable automation are key to staying agile as new guidance is provided. Because we're learning about this virus week by week, month by month, and new guidance will come out, using automation really helps to deal with that sort of rapid knowledge that things are coming out. So if you're using hardwired controls or you're using canned sequences, they won't be as valuable to you as flexible automation programming. For example, you want to use more outside air. If you have some sort of an economizer mode on an air handling unit, and you want to take in more outside air, it may not be something that's easily done on a canned sequence. So we really stress customizable automation. SARS-CoV-2 differences aside, this general science of virus transmission is well established. For years, groups like ASHRAE have done studies on virus transmission through air conditioning systems and all. So the good news is there's a lot of good practices and knowledge out there about stopping the spread of viruses. And the data that we would gather to do virus mitigation is also very useful for energy management. And we'll talk about that in some detail later about the value, the things that you do to mitigate COVID-19 spread will also have other value. So let's talk about particle sizes. This is a diagram from ASHRAE, and it shows particles of different sizes. On the left, it shows a particle that is 0.5 microns. It's very small, half of a millionth of a meter across in diameter. And what this tells you underneath is how long that particle will float around in the air before it, here it says drops 5 feet, but let's just say hits the ground, hits a surface. So at 0.5 microns, it'll float around for, let's say, 41 hours. If we double the diameter of that thing, it goes down to 12 hours. At 3 microns, it's 1.5 hours. And if we get as large as 100 microns, it'll drop 5 feet in 5.8 seconds. So this is very important. In analyzing the spread of diseases, we really care about the size of the particles. So big particles are better for us. They don't transmit as easily, whereas these small particles do tend to hang around more and cause a lot more trouble in air conditioning systems. So the current research is good news. The definitions above 5 microns, they refer to as respiratory droplets. And I'm sure a lot of you have heard that term recently, droplets. And below 5 microns, referred to as droplet nuclei or aerosols. The size of the SARS-CoV-2 virus itself is much less than a micron. It's 0.12 microns across if you just isolated the actual virus itself. But according to the World Health Organization, the current evidence, the COVID-19 virus is primarily transmitted between people through respiratory droplets and contact routes. So that's really good news, and I'm sure a lot of you have heard. It's the large wet droplets that are expelled when people cough and sneeze. That is the primary method of transmission of the virus. So let's look at the virus, and here is a nice diagram of how humidity affects the virus. So if it starts in large droplets, we see a wet large droplet on the left, and humidity can actually help us. It's one of the measures that we can take is higher humidity. That's proven out both in laboratory experiments, as well as if you look at the countries that have the higher spread, they typically tend to be colder and drier climates, or those countries that have the highest spread. So if you look at this droplet, for those of you who know about humidity, the drier the climate, the faster liquids will evaporate. So here we show a large droplet and evaporating. So we want those respiratory droplets to remain large. Lower humidity will more rapidly shrink the size of the droplets as they evaporate. So humidity particles primarily affects airborne particles, not those on surfaces. So lowering humidity will help us with airborne particles, probably not so much for those that are on surfaces that we touch. So the recommendation is that you keep humidity in buildings around 40 to 60%. That 60% upper boundary is really, if we go above that, as a lot of you know, we'll start having problems with mold and property damage and stuff like that. So it's close to 60 as you can get without going over it is probably best. So humidity, raising humidity inside spaces does have some effect. I'm going to do a couple of studies. This is a restaurant in China. And when I first heard about this, you know, as most of us probably been reading news since this outbreak happened, a headline very early on caught my attention, and it said air conditioning spreads the COVID-19. It turns out that headline was quite misleading. On the left-hand side, you see a floor plan of the restaurant, and those round circles and square circles are squares are tables, and on the right is a blow-up of the tables in question. And this was a really good study because one person had already tested positive for COVID-19, went into the restaurant and actually spread it to other people. And they had a security camera in there, so they actually had video footage of it and everything else. But what you can see, that A1 is the yellow circle that is in the center there on the right-hand side of table A. That was a person that was positive for COVID-19 when he went into the restaurant. And off to the right, you'll see an air conditioner. They don't go into detail about the mechanical system itself, but you can assume that this is a package unit that is against the wall, blowing air horizontally across those tables. And there's a return that picks up in the same place. So there's quite a lot of ventilation across those three tables. So the spread of the disease in this case was, first off, close contact. And where it jumped across tables, it was in an airstream. So a lot of tenants in buildings and all are going to have to rethink furniture arrangement. Obviously, you don't want people sitting close to each other if that can be helped. But in this case, the air condition did contribute somewhat, but in most large commercial buildings in the United States, they aren't really arranged like this. Air is dropped down from the ceiling, typically VAVs, out of diffusers. And it's also usually not high velocity air blowing across horizontally like that. So that's good news. It isn't, in this case, it isn't spread by central air conditioning. It's not going through filters. It's not being recirculated throughout the entire system. And you can see that the virus spread is limited to those 3 tables and really didn't jump across to any other tables, even those right next to it or throughout the rest of the restaurant. Here's another study, is a call center. This one's in South Korea. And there's a floor plan off to the left. Now, this is starting to look a little bit more like the buildings that we work in typically. It almost seems as if it were to scale, but the more I stare at this, I realize it's not to scale. It's an illustrative drawing. But what you have are a bunch of people in call centers that pretty much sit in the same place every day. And they have spread really on one particular floor. And you can see the ones in blue are those that have contracted COVID-19. And for the most part, they are physically close to each other. There is a central air conditioning system. And the result of it was that they believe that the virus was transmitted person to person. People sitting next to each other. There are a few isolated people on the other side of the floor, but these people work together all day long and move around a lot. So there's probably a normal explanation to that. What we didn't find in this study is that it went through the air conditioning system, went through filters, and so on and so forth, which if it were an aerosol, it would remain in the air a lot. It would be brought into the return duct, possibly pass through filters and be spread back out. It would look a lot different than this cluster here. So COVID-19 spreads mainly among people who are in close contact within about 6 feet for a prolonged period. I'm sure a lot of you have heard that a lot. So the key here is close contact and also prolonged period. Obviously, if you're walking down the street and you pass in front of someone, if you are unlucky enough to be next to them when they sneeze or something, there is some risk. But the primary spread is close contact for a prolonged period of time. So work environments are very important, as we know from the meatpacking plants and other such places that have been in the news. Physical distancing, again, is the primary means of reducing the spread of the disease. Secondarily, it may be possible that a person can get COVID-19 by touching a surface or an object that has a virus on it. So again, if someone who's sick touches a doorknob, another person comes along later, touches the same doorknob, and then touches their face, it certainly is possible, but that is not the primary means of transmission. Let's go back and do a little bit about indoor air quality. I think a lot of people in this webinar are those involved with mechanical systems, and also this would be a refresher for you guys, but it's certainly worth going over, especially for those people who are not familiar with it. So indoor air quality generally describes the quality of air and the health inside of buildings. Often, sometimes you hear a more broad term called indoor environmental quality, but here we're just concerned about the quality of the air. So we start with contaminants. There are many contaminants that can go into the building. We are primarily concerned with CO2 in this case. It is the only one that is actually spread by people. Well, Legionella and some of the other ones are, but typically you separate those contaminants by people from those that are just being emitted from other sources. So we make a distinction there. The list of possible contaminants in a building is very long, and we could probably do just an hour. So we're just listing some of them there, but the goal here in indoor air quality is to reduce the amount of contaminants. So methods, there are 3 primary methods to increase indoor air quality. First is source control. This one's a bit obvious, but if you know there's something in the building that's creating pollution, you go to the source and you eliminate it or reduce it. And that really doesn't concern building automation much. That's sort of an old school low-tech method. Filtration is the next, and a lot of you are familiar with filters in buildings. Home air conditioners have filters, large commercial HVAC systems have filters. So filtration is a way that we can directly remove particles out of the air. We'll cover that in some detail. And then finally, ventilation, and this is probably the biggest one that in relation to COVID-19. Ventilation lowered the concentrations of indoor air pollutants by increasing the amount of outdoor air coming indoors. So those are the three methods for improving indoor air quality. This is a little refresher of a commercial air handler. We're skipping a lot of the elements you would typically see, cooling and heating and so on, but we just show those elements that are related to indoor air quality. So the return air all the way at the left is air coming from the space that's going to be recirculated back into the space. From top, we have outside air. There's some ductwork method of bringing fresh air from the outside, and together the return and the outside are mixed. Then they go through a filter. The fan blows it out to supply back out to the space. So that's the sort of basic element of an air handler in a commercial building. Filtration. So on that filter, there is a term that a lot of people use, and it's MERV for short, which stands for Minimum Efficiency Reporting Value. This is a metric designed by ASHRAE, and it reports the effectiveness of filters. So here we go from a MERV 3 at the top all the way down to a MERV 13 at the bottom. And what we're doing here is we're basically, as the MERV value increases, we are filtering out smaller and smaller particles. When you get above 13, you would typically refer to that as a HEPA filter. Those are the type of filters you'd find in hospitals. But in commercial air conditioning systems, this would be the typical range. Over on the left, you'll see household dust. Those are big particles that we can pick up pretty easily with almost any filter. If you look at the MERV 13 down at the right, the smallest one there is virus carrier particles, right? So we're very interested in those particles. But as you'll see, and as we hope, we don't think we need to go to a MERV 13 to eliminate the SARS-CoV-2, because that it isn't just the virus in an aerosol form. It typically is the virus in a larger droplet. So this next chart shows that a MERV rating of 13 will catch 90% or more of particles in the 3 to 10 micron range. So a 13 would be a good investment for people if they want to do better job at filtration. But filtration really comes at a cost. So as we go to higher MERV values, certainly the filter itself costs more money, but that's not the real problem. The real problem is that filter has smaller holes in it, and it's tougher for the air to go through. So we get a pressure drop. Now, it's not quite as linear. This was a study done by this homeenergy.org, and they show a bunch of different filters. But clearly, the MERV 13 at the top has a much higher pressure drop than the MERV 2 all the way at the bottom. And I'm sure it's dependent on manufacturer and so on and so forth, but clearly the higher MERV rating is a higher pressure drop, and that translates into higher energy costs. The fan's going to have to work more to pull air through these more efficient filters. So this is pretty much the same thing, but it shows fan energy. So as we'll show later, we're very concerned about the value of all of the investments and the true cost. So this is something to keep in mind. Certainly, higher MERV rating filters produce better indoor air quality, but it's going to cost you in terms of energy and fan motor power. So the other final indoor air quality method is ventilation. So ASHRAE breaks ventilation down, ventilation requirements down into two pieces. The amount of air that is required for a space is depending on the people and on the square footage. So CO2 is a contaminant produced by people, and most of the other contaminants have little or no relation to people. So we're going to use a minimum amount of fresh air for spaces based on ASHRAE, and one part is proportional to people, and the other is proportional to square feet. So we got a little math here. This is ASHRAE 62.1 2019. It shows a formula, and I don't want to beat you to death with math, but that first parentheses is proportional to the people plus the second one, which is proportional to the square feet. So as we'll show later, we're introducing a people counter, which is inexpensive wireless battery operated people counter that will help mitigate some of the new regulations for COVID-19. But also it really comes into play here for demand control ventilation. So if you know how many people are on the floor, you can reduce the amount of air or get the right amount of air based on those people. But of course, ventilation, just like filtration, comes at a cost. I tried to find very simple charts and graphs for the cost of ventilation, but unfortunately, it depends a lot on geography. If you live in California and you have cool, dry air, it really costs very little to nothing to bring in outside air. Whereas if you're in the deep south with hot, humid air, it's much more expensive. So here are just some quotes from the EPA. To meet the ASHRAE standard for very high occupant densities, it's a significant energy burden. So if we were to raise from 5 to 15 CFM per occupant, our HVAC energy bill would go up 15 to 32%. That was one study done by ASHRAE. However, if it's modestly populated, you have modest increase in cost. So where we have 7 people per 1,000 square feet, the HVAC energy cost goes up 2 to 10%. That's not bad. But with 15 persons per square feet, HVAC goes up 21%, and the total energy bill went up by 8%. So you can see the costs certainly go up as you bring in more fresh air, which will help with COVID-19, but it won't help your energy bill at all. It'll increase air quality, and that's one of the main recommendations you'll see from most outside people is just use more, bring in more outside air, but remember the cost here. There's a balance. So the next section we're going to here is virus prevention measures. We're going to cover a few. We're just going to do a brief, low tech. Then we're going to go over virus prevention measures for building automation. We're going to look at virus prevention measure value and then new tech. So let's get started on that. First, to define it, for those of you who are familiar with ASHRAE's energy audits, they use 2 terms. One is EEM, excuse me, and it's defined as energy efficiency measure. An energy efficiency measure is when you do an ASHRAE energy audit, you basically go through the whole building and you come out with a list of things that can improve energy efficiency that really don't inconvenience tenant comfort at all. They're simply eliminations of waste. And those of you who have been through that process know that at the end, there are a few that pop out that are just sort of the best, the most efficient for the least cost. There are also ECMs. These are energy conservation measures. The concept is similar. It's just that for ECMs, you are asking tenants to make some sacrifices, whether that's higher temperatures or a later start time. But in an internal energy audit, engineers organize EEMs and ECMs value and make value decisions. So we're sort of extending that same concept to virus prevention, and we introduced the term virus prevention measures, VPMs. And we feel that moving forward that you should use the same rigor that you would use in an energy audit to go through your entire building, write down those ideas, those virus prevention measures, that you feel would have the greatest impact for the least amount of money. So value is a huge thing that we need to consider. If you, for example, just say, well, I'll just take in maximum outside air 24 hours a day and I'll never turn it off, you will certainly make for a safer environment, but you may not be able to afford to do that. So for these virus prevention measures, we're going to cover value a lot. Here's some low-tech stuff, and I almost hate to put it in here, but I had a few comments from the last one, but I believe there are a lot of people out there that are doing this. So, of course, require face mask, close unnecessary public gatherings. The CDC, by the way, has a new guidance out with guidelines for different types of businesses, and there's a lot of this stuff available. Limit traffic in elevators, provide hand sanitizer at key location, use touchless hand sanitizer dispensers, make stairwells, hallways one way. There's a long list of these things. I could probably just spill out pages of it, but these are low-tech solutions that I have a feeling most building engineers are already on this type of stuff. Most buildings are already doing this type of stuff. So we're gonna breeze through the low-tech stuff. Building automation is our comfort zone here. So we're gonna go over some of the top concepts for reducing the virus in just using existing building automation. Higher temperature, again, this is the sort of least effective of all of them. Higher temperature, certainly the virus likes lower temperature. Raising the temperature would sort of mitigate it a bit. But in the range that we're working in, let's just say 68 to 75 degrees, there's very little effect on the virus from everything that we know about it. If you had a 55-degree space and you could raise it to a 90-degree space, that would probably have a significant impact, but that's unrealistic. Humidity, as we discovered, does have a significant effect. Although, depending on your geography, climate, time of year, that may be easier or more difficult. But certainly, we want to keep humidity in that 40 to 60% range. Better filtration, as discussed, that certainly can reduce the virus transmission. Better ventilation. But all of those things are things we can do with our building automation system and our HVAC system as it stands now. But the number one thing that we really want to take advantage of is this physical distancing. So I use the term physical distancing as opposed to social distancing. As we know, we can be physically distant and still remain social today. This meeting is evidence of that. So physical distancing is the new standard, and it's something that we're trying to adjust to. And we have some clever ideas we think will help in this area. But before we do that, we'll just run over some of the standard building automation programming guidelines. I must say I was a little disappointed in ASHRAE's response to it. They do have a large response document, but it seems lacking in very concrete recommendations. Originally, ASHRAE hyperlinked this site. This is sort of the European ASHRAE. It's the Federation of European Heating, Ventilation, and Air Conditioning. It has what I find to be a very practical set of measures. So I won't run through them all, but they're quite to the point. And the website is located here. So this is a summary at the end of this page. Secure ventilation in spaces. They talk about heat recovery, make sure there are no leaks, and so on and so forth. So for every one of these, there is a detailed explanation, and this is a good resource for anyone going through their building automation system and their HVAC system to prepare it without doing a whole lot. These are just good recommendations. So there are a lot of considerations when you're going to go into your building automation or HVAC system and make changes. Geography, again, if you're in a dry climate, you can just take in tons of fresh air, dry and cool. If you're in a hot, humid climate, that may not be that easy. Newer buildings in hot, humid climates may have prepared for doing free cooling, large amounts of fresh air being taken in. Older buildings may just be restricted as to how much outside air they can take. CO2 sensors, adding CO2 sensors to a standard building automation system, we find to be one of the best investments. Besides just monitoring indoor air quality, CO2 is the one sort of metric that is directly proportional to how much air other people have exhaled. It sounds a little funny when I say it, but if there's high CO2, there's probably high respiratory particles in the air as well. So measuring CO2 in lots of places and doing whatever, whether it's automated or manual mitigation of that is a very easy mitigation. And I don't know how many of you have good estimating tools for energy or do HVAC system modeling, but it really is an invaluable tool if you can do it. That is, estimate the cost of what you're about to do before you do it. So for example, back to our ventilation example, if you just start taking in massive amounts of outside air and do whatever you need to do to cool it down, and you wait till the end of the month to find out how much that cost you, you may be shocked. If you could do some method of estimating costs of these virus prevention measures before you do them, that would really help your decision making. So assuming limited resources, you must consider the value of the investments. Some COVID-19 VPMs may actually be free or even save money. Raising humidity, for example, in a humid climate actually will save you money because you have to spend energy to dehumidify. Of course, if you're in a low humidity environment and you need to raise humidity, you're going to have to buy humidifiers. That may not be a sound investment for you. And choosing investments with multiple purposes adds value, and we're going to go over that as well. We'll give you some examples of that. Added value can be energy savings, improved air quality, or tenant comfort. Take, for example, CO2 measurement. It's critical for both indoor air quality and COVID-19. Fresh air ventilation, same thing. Filtration, but they both have implications in energy usage. So as we're going through this, and bringing people back to work, you have to consider the value. One thing that came out just recently is the U.S. Green Building Council they came up with a new slogan, healthy people and healthy places equals a healthy economy. I don't think they're going to win awards for marketing with that slogan, but you can see their shift towards healthy buildings, especially in terms of COVID-19. So they've done a couple of things. They're going to upgrade LEED 4.1. They'll make a series of changes. So they'll allow people to get LEED points for things that they might be doing in the building. So for those of you who care about LEED and are actively pursuing LEED certification, this might be something for you. For those others, this really would not have value for you. But on an emergency basis, we will promptly release LEED pilot credits to support social distancing, non-toxic surface cleaning, air quality, and infection monitoring. So that's good to know. It might help justify spending some of the money that you would need to spend to do these things. So we're going to go through some new tech that we've been working on that might help people get back to work. So you've heard this a lot, getting back to work, hotly debated topic. I don't think you can turn on the news without hearing about it. But government agencies, both federal, state, and local, will have different guidelines. But ultimately, it's up to the tenants to determine whether or not they're going to go back to work. I think this is something that's often overlooked. You can open restaurants, but will anyone show up? In our industry of commercial real estate, you can open buildings, you can welcome people back in, but I think we're all a little concerned about perhaps they won't come back in. So we feel that tenant engagement is one of the best ways to get people to come back to work, is to make the building safe and communicate the things that you have done to encourage people to come back to work. If nothing else, you remain transparent and you let them know the things and let them make the decision themselves. Without it, they will in many cases, be scared to go back in the building. So it gives your tenants peace of mind. And whatever money you spend to prepare the building for sort of a post-COVID-19 return to work, if you don't effectively communicate it, I mean, obviously you're trying to stop the spread of the virus. That's the number one reason you do it, but you're really doing it to give your tenants peace of mind. If you don't communicate to them, that part of that is just lost. So we put together what we call storyboards, and there are a lot of, dashboards out there. We've done lots of dashboards, but what we're trying to do with our new design storyboards is to reduce the technical information and give the tenant a story of coming back to work where we explain what we've done and why it's important. So this one, has an air quality rating over on the side that, shows tenants they could log in from a website, see their space, see what's going on, and get a feeling for not only what is being done, but why that's good. Here we show a floor plan, similar setup, but it shows the actual individual spaces. Here we show a floor plan, and this one I've included the occupants. So if you have people counting, you can see the red zone. There are 18 people in that small space. Accordingly, the CO2 is quite high. Those two things are very closely related. You can almost guess how many people are in a room by measuring CO2. And if I were deciding whether or not to go to work today or to work from home, if I pulled that graph up and that was my office and there were a lot of people in it, I could make a knowledge-informed decision about whether or not I want to go to work. Quite frankly, if I could pull up a website of my grocery store and know how many people are in the grocery store, that might help me decide when I'd like to go to the grocery store instead of going when it's very crowded. So the storyboards are tenant-facing dashboards that give tenants critical information. And CO2 and people counting are the two things that we feel are the best. Looking at the time here, 10 minutes. Looking at people counting and CO2 are the best value. This is a simplified dashboard that really just gives you the big jumbo numbers, and it would be for one particular space. And in these storyboards, we can, for each login, focus them on just a single web page that's tailored towards them. So this one is, for example, floor one. All tenants on floor one would have access to just this. So tenant engagement, we really think, is super important in coming back to work, as well as the quantities that are displayed here. And you can see fresh air changes, CO2. So if you're missing some of that data, you're probably going to want to upgrade and get a hold of your CO2 levels, people counting if you can do it, fresh air changes if you can do it, if you have those measurements. Another sort of overlooked indirect way of getting physical distancing is just a good old access control system. Many people use access control for security, but access control can actually provide physical distancing. So you might have a crowded lobby, and maybe you want to say, for the time being, people can't just walk in off the street. You have to be a tenant in the building to get in. You may want to, require visitor badges for vendors and whatnot. They'd go to security, you print a little badge, and they have access for one day. You may want to further subdivide tenant spaces. For example, you might have a tenant that covers 3 floors and any employee can go to any part of those 3 floors. You may want to crack down on that, put more card readers, and have people just go to the spaces that they are required to go. So it's sort of an old school way of using your security system to also provide physical distancing. Here is we have a new line of wireless products coming out, and this is our new digital wall stat that is paired up with the VAV, but it can be sold straight up without the LCD and the measurements. It has a temperature sensor, a humidity sensor, a CO2 sensor, and a VOC sensor. These VOC sensors are volatile organic compounds. Those are a whole array of pollutants that are organic and evaporate very easily. Think gasoline. If you left a can of gasoline open, it would evaporate very quickly. A VOC sensor would pick that up. So you've got indoor air quality, you've got CO2, which is a great indicator of people and virus transmission, just general pollution sensing, as well as temp and humidity. Wireless, battery operated, so you pretty much just fasten it to the wall. This is the one that we've really been pushing in development. It's not a real product yet, but it's a people counter. And it has, the one we're designing has 2 infrared motion sensors and 2 what are called time of flight people sensors. The reason it has so many sensors is for accuracy and power management. So the infrared stays on all the time with very little power draw. As people get close to it, the processor inside turns on, and those TOF people sensors kick in. They're very accurate, and it keeps count of how many people have gone in and out of a door. Typically, this would be mounted over a door. You can put them in front of spaces. Again, they're battery operated, wireless. And what you get by deploying many of these is the occupancy of different suites, floors, wherever. And that's absolutely critical information, especially when you have guidelines that say 25% of capacity. How would you police that without some sort of a people counting at the front door? There are a few others. Scott, I'm going to hurry up because we've got a little bit of a late start with my technical difficulties. But there are a few other things that we're looking at. One is general phone counting. This is a technique where you simply pick up wireless signals from phones and try to estimate the people in the space just based on phones. This has a lot of pros and cons, which I will not go into. Just some research. RFID badges. These are great. You can track a person wherever he goes in the building, but it does identify the person uniquely, so there are privacy repercussions. Unlike the people counter, which is not a camera, it doesn't identify individual people, it simply counts people. There are custom tenant apps. We're using an app right now for our wireless devices. We could extend that to customers. The tough side on this one is participation. Could we count people based on their use of an app? That would require participation. And finally, I don't know if you guys have heard, Google and Apple have gotten together to create, I call it an app, but Google and Apple are actually changing the operating system, allowing governments to produce apps. But this one keeps track of all the people you've been near. And if one of them tests positive for COVID-19, you can get an alert to go get tested. This has nothing to do with building automation. However, there is talk that they would let third parties count people based on the signals emitted. So we're looking at that as well. So those last ones are really just research items. But certainly there's a lot of work. There's a lot of new stuff coming out that's going to help people manage getting back to work. This final table here is a summary of sort of all of the things that we talked about in the value. And at the top, we put people counting number 1 because it pretty much goes across the board. It's very effective in virus, mitigating the spread of the virus. It will help maintain comfort. As we said, ASHRAE standard is so many CFM of fresh air per person. Knowing exactly how many people are in each space will help. First responders, if you empty a building because of a fire alarm, if there are people left, the first responders could know. There's a term in security called tailgating. That's two people going through the door because the first guy swiped his card. People counting can help that. Energy management, demand control, ventilation, so on and so forth. For real estate managers, knowing how many people and doing traffic studies of where people go will help you manage your space better. So we feel like that's sort of the number one value is people counting. CO2 is running a close second for the same reasons. A tenant portal, some sort of a web or app that tells your tenants what's going on in the building, in their space, access control, and of course, ventilation and filtration at the end. But be aware of those impacts to cost and energy usage of those last two. That's it. Scott?
Mike, that was great. But I do want to mention, if the storyboards product or anything, Mike talked about today is of interest to you, we do have our contact information up here, and we highly encourage you to get in touch with us. We've also had Kristen McLean on our webinar today from the Vivid Ink Company, who produced a graphic based on the content in today's webinar. Kristen, if you'd like, you can go ahead and pop that up on your screen share. And there we go. If there's anything else you all need, you can reach us at info@computrols.com. Otherwise, thank you all for attending the webinar today. Thank you, Mike, for presenting. There's a lot of great information. And thank you for Kristen. Thank you to Kristen for producing this amazing graphic, which we'll be sharing with everyone after the webinar. Everyone, have a great day and stay safe.